Hey guys, how's it going? In this video, I'm going to walk through this Leetcode 1710 maximum unit on a truck. And this question was asked by Amazon for 42 times in the past 6 months. So it was quite popular in Amazon interviews. And luckily, this question is kind of easy. Let's walk through. So you are assigned to put some amount of boxes onto a one truck and given a two-dimensional array. It's called box type. So the data looks like the first element is the number of boxes, and the second element is the number of unit per box. So we are also given a integer of truck size, which is a maximum number of boxes that the can be carried by the truck, and we can choose any boxes to put on the truck as long as the number of boxes does not exceed the truck size, and we need to return the maximum total number of units that can be put on a truck. So let's look at some example in here. We are given a data looks like this. So it means we have one box of the first type, which is this guy over here, and that contains 3 units. Each box can contain 3 units. Okay, and the second type, and we have the 2 boxes of the second type, which is this guy over here, and each box can contain 2 units. And this is the third type. Okay, so 3 boxes of the third type, and each of the box can contain 1 unit. And the truck size is 4. So the maximum unit that this truck can carry is equal to 8. So the math works out to be the truck can finish all the boxes of the first and second types and one of the box in the third type. So when the truck comes in, we always want to put on the boxes that contain the maximum, the more units for it. And by doing that, we will make sure that the truck can carry the highest amount of units. So and in this case, the first type, each box contain the 3 units, which is the highest among the 3. That's why the truck can come in and pick up the first one first, and then pick up the second one and then the third one. So one way to do this is to sort the data by number of unit per box. So using a descending order. So the truck will pick up that box first, and then the second one and third one, and that will work, but it's kind of expensive because uh, for each iteration, for each of the task, so we are guaranteed that we have to sort this list. So it's the time complexity is it must be n log n. So a slightly optimized way to would be use a priority queue. So in the case if there are more boxes than the truck size, we don't have to do n log n anymore. And so the worst case is still the same, n log n, but in an average, the priority queue will be better than the sorting approach. I'm gonna export the priority sorting approach in this solution. Let's dive in. So first, we put all the box type into a. So basically, we use the unit per box as the weight, and because in Python it's always a min heap, and to make it to turn around and make it a max heap, we can put a negative sign in front of it. So I call it like a sort weight. So when we pop it off, the one that has the highest unit of per box will comes out first, because again I put a negative sign in front of it, and then I put it back with the box type by pushing the sort weight. The sort weight it is the first element. Second element will be the same number of boxes and also the unit per box as before. So essentially what I was doing in here is just I extract this information that allows me to sort it later on using the min heap, or now I put a negative sign become a max heap, and I use a heapify to turn this list to be a heap, while we still have room for the chalk. And if there is some box that can be put in on the chalk, and then we heap pop the box types. And this operation takes a big of a log n. And if the available boxes is less than the chalk size, and then we append the total number of units, which is equal to the number of boxes times units per box to the answer. And then now we put the box on the chalk, and then the available room will decrease by the number of boxes. And else if the number of boxes is equal to the chalk size, we append the number of boxes times the units per box to the answer, and then we don't have to do this while loop anymore, because now the chalk is full, and then we just return the answer directly. And else if the number of boxes available is more than the chalk, so now the chalk is full, and we append the unit per box times the chalk size to the running answer, and again we don't have to do the rest because the chalk is full. And then we exit from the while loop and answer, and then return the answer. If the available boxes is less than the number of available boxes is less than the chalk size, this is where we will. Sorry, this is the number of boxes is more than the chalk size. This is how we'll exit this while loop, and we will just directly return the answer. So let's run that to see how it works. So as you can see, it looks okay. I already analyzed the time complexity, but I just want to emphasize a little bit more. So the time complexity in the worst case scenario is big over n log n, which is same as the sorting method. But on average case, we don't have to go through the entire box types. If the chalk size is bigger than the box types, and so in that case we don't have to go through the entire box types, and this is where we can save some time compared to the sorting method. But this is talking about the worst case, and also as big over n. So this is where we generate do some data manipulation in the box types. So the sum of the two is still equal to the n log n, which is the dominated part. And for space complexity big over n for the official solution, actually we didn't use actual space in here. I did everything in place. So for me, this solution is only a bit of 1. Yeah, so this is so much in my solution. I hope this is helpful. If it is, please like and subscribe, and that will be a huge encouragement to for me to create future videos. Thank you so much for watching. I will see you next video.